So I mentioned I'm Enrique Herrera. I'm looking at this track. Obviously, we've got this topic on open innovation at the edge and us delving into open source. So for that, I've got the CTO of Dianomic, who will be talking about kind of innovation at the edge using open source. So let's give him a hand.
Thanks, Enrique. And boy, I'll tell you, that's a tough act to follow. I've been out at Rob's. I don't know how many of you are still in the same audience from this last one, but he runs this AU Ops Center at Barrick, and it is an impressive thing. And he's got such an impressive background. I have no military stories, but hopefully you'll get a lot of value out of this. You may have seen in the keynotes that Pat talked about open source and about some of the investments that OSI is doing in this. And then you probably saw that Greg and Penny talked about data acquisition and this pervasive data collection and how important it is. And then Chris Feltz, of course, talked about FogLamp and open source as part of his presentation as well. And so I'm going to talk a little bit more kind of the next level of detail on that. And especially, I'm with a company called Dianomic. We make a open source data fabric called FogLamp, and OSIsoft is an investor. Pat Kennedy's on our board. I'm Bill. I'm the CTO. My background, my last gig, I was at Oracle. I was a group vice president. I managed about 1,100 developers. And before that, everything I did was all startups. So it's 2 guys in a garage, and if all goes well, you build it up to 500 people. And I had the good fortune that 5 of the companies I did got sold for about $500 million to Oracle and Avaya and Alcatel and others. And it's always an exciting thing when you're starting off one of these companies because it's always something that's new and potentially changing the world. And I think that's a lot of what we're doing here is something that really can change the world, especially the OT world. Do I have a clicker, by the way? Is this my guy? Let's see if I'm doing the right thing here. This may not be a clicker. Here we go. Okay. So if you haven't seen the slide, a lot of the presentations are going to start off with these slides. And so some of the things we're going to be talking about IoT data and sensor-based data. And but the thing is, IoT is so pervasive or so potentially pervasive in the future that you're going to see just tons of it. And so how do you deal with the management of it? How do you deal with the provisioning of it? How do you deal with the updates and the maintenance of it? Of course, security is an issue too. Now you have this much larger attack surface area to deal with. And we think that one of the most important things to deal with the complexity and the fragmentation of IoT is that you have to have open standards and open solutions so that everybody adopts them, and then you have open communities because everybody is not just adopting them, but they're contributing to them. And then you have ways that everybody works together and the world is a better place. That's what we're building. And of course, this all comes down to a community. This is important both to companies to use inside, but it's also important to integrators because people who are building the solutions. And of course, this is all about the digital transformation of your business. So actually, just a show of hands, how many folks in their companies, whether you're building solutions or whether you're inside a company that's an end user of Pi, how many of you actually have IoT projects going underway? And how many of you are thinking about projects underway or kind of thinking about it? Yeah, good show of hands, yeah. There's a lot of folks that are seeing things, they see the massive potential, and there's a question of like, well, how do I actually engage? How do I collect some of those? And so I'm going to talk about, first of all, the fragmentation and complexity that FogLamp addresses, but then I'm going to walk through a use case that hopefully will be relevant to many folks. And then one of the challenges that immediately happens is how do you scale this and how do you deal with the provisioning and management challenges? So I'm going to talk about how ARM and some of their open source technology was used at this particular defense contractor to solve their problems. So first of all, talking about IIoT in general, so there's a number of trends, and this has been happening, but we seem to be now hitting an inflection point. So these sensors, they're cheaper every day and they're smaller every day. So now you can go to Fry's and get something for $1 or $5 that can do something quite valuable. Now at the top end, you've got compute and storage costs are going down in price. You've got all these new tools for doing data analysis and transforming that into information that you can use. And of course, connectivity is becoming much more ubiquitous. So even out on, whether you're on an oil rig or whether you're in a mine or wherever, you just now have new ways to connect all these things. So you put all those pieces together, and pretty clearly there's an opportunity to change things dramatically. So I'm going to talk about the massive fragmentation inside that. But the first challenge is that when you've got this fragmentation, you really need, as I say, an open standard. You need something that everybody agrees how to speak, and you need software that adopts to that. And as I say, Dianomic has built this product called FogLamp. It's based on the Open Fog Consortium, standards body. IEEE is involved with that. And FogLamp is available on GitHub today, so it's free, and you can go and play with it as we speak. So if you look at the problem, you've got a plant manager. They're working with all the data that they're collecting through PLCs and SCADA systems and other. They've got it all going into their Pi system, and everything's going great. So now you've got this new green world. So you've got all these new IoT devices. And whether there are initiatives that come from vendors or whether they come from custom-built solutions by SIs or whether they're internally built by a company, you end up with these solutions where, for example, you might have some vibration sensor that you plug onto a machine, and the manufacturer will build a great web app out in the cloud that tells you when it'll predict when the machines may break down, or it'll tell you the use cycles of those machines. And this is great. So now the plant manager has access to that information. But now as you see these additional things going on, you end up with this very fragmented market. So now the data is all siloed, and the plant manager who is used to seeing his data in Pi is no longer seeing that. Instead, they're seeing this through all these different fragmented solutions. There's question of even who owns the data, because when it's in the different silos, it may not even be owned by the plant manager. And of course, then you have no context. You can't mash one piece of data with another. You can't join them and find solutions across that. So that's where FogLamp comes in. FogLamp, when it's used to build when it's used to do the data acquisition, you can deliver the data into Pi, and you can also deliver it where you need to, and everybody works together happily. So what FogLamp actually does, at base, it does data collection, so you can have sensors connected to it, and it collects data. It can aggregate that data, so you can have multiple sensors feeding data into a larger FogLamp. It can do pre-processing, so you can deal with data so that if you have redundant data, that it doesn't send all of it, or if you have, say you have failover information, so data's only being used when another device fails, that sort of thing. It does buffering, so if for example, say you've got FogLamp installed on a haul truck and it's collecting data as this haul truck is going through a mine, well, when you may have spotty connectivity in that mine, and so it'll automatically sync up as connections come in and out. And you can do some very rudimentary analysis out at the edge to kind of understand what's going on with the data. FogLamp runs on various hardware and operating systems, primarily Linux, different variants of Linux. It's designed to be very easy to provision and maintain, so you can put it out on a place that out on some water line that you never deal with. It's like a cable modem that you turn it off, turn it on, it just always works. It's designed to be resilient and highly available, so that if you've got, you can set it up so that you've got one, and if it dies, another one it'll fail over to, and it'll keep living. Designed to be very extensible, so it's modular, and I'll get into more detail on this, pluggable, and you can build external applications that leverage what's going on inside it. And of course, it speaks to Pi. So whether it's your local Pi server, whether it's the new Edge data store, whether it's OCS in the cloud, it can deliver data out to Pi. And it's all standards-based, and as I say, it's available on GitHub today. So this is an architecture of what it is. There are 4 core, it's got a modern microservice architecture. There are 4 core microservices. So at the south side, you've got the south service sits there and it collects data. So whether it's embedded in a sensor or whether it's collecting data across a network, and over time there can be more types of interfaces that plug into this south service. The data then flows into the core where various pre-processing can be done. It's pushed into a buffer with the goal of, as I say, if there's spotty connectivity, that the data stays alive even if the device is powered off and back on. And then the data is then goes out through the North service and out to Pi. The whole thing is accessible via REST API. So there's some admin APIs. There's a GUI on it, but it also has the GUI uses the admin API. So if you have your own tools, they can easily connect into it and manage it directly. And it also has an application API, so you can have external applications that live with it or live externally, and they can access the data and inject data and so forth inside it. You can use it as it stands just like this. So you've got a sensor connected directly to Pi, or it scales up and down. So one example of scaling up is that you can take just the northbound service that has this Pi connector. There's a protocol that OSI developed called OMF that I'm sure you've heard of. That this has an implementation of OMF. And so you can plug this into a router or a gateway device, and now that router or gateway device has connectivity to Pi, and so any kind of devices you have can now talk through that router and go there. And if you go to the fog lamp booth, there's actually a few vendors out there who are doing exactly this. So Beyond the Edge Networks is doing this, Panduit is doing this, Arrow is doing this, and yeah, it's exciting. So the other way it can scale down is that you can take these components and split them apart. So you can tease off the south service and put it in a separate device so that it can live in a smart sensor that's very, very small. So, you know, literally a $5 item with a 50K footprint can now be placed. I mean, it's a disposable sort of thing at that price point. And then it talks to the gateway componentry at the top end, which then sends the data to Pi. And it can also scale up. So as I say, you can download it off a fog lamp, you hook up a sensor, you hook it up to Pi, and now data is flowing. But it can also be, you can have multiple sensors, you can have hierarchies of these things, you can have redundant ones, you can have it sending some to different Pi servers, one perhaps to OCS in the cloud and one to a local Pi server. So it's very, very flexible. And really, one of the biggest values of open source is it's not just code, it's people and it's community. And so I think we're very fortunate that we've had some great vendors and great companies that are now part of the Fog Lamp community. So OSIsoft, of course, ourselves, ARM, and I'll talk a little more about ARM's involvement in a bit. Sprint is involved, Arrow, Panduit, Toshiba has their Flash Matrix device. And Beyond the Edge Networks, and the community is growing. So, and of course, we'd like you to be involved. So, open source is all about people who use it, people who feedback, whether it's code contributions or whether it's just feedback of, hey, this isn't working, bug contributions, or feature request contributions. So the whole thing is driven by the people, and we want you, the people, to be involved in this. So now here's a use case. This is I can't say their name, but they're a major military aircraft manufacturer. And they've got a dozen massive manufacturing floors. They've got things that are manufacturing the fuselage. They've got whole areas devoted to cabling. They've got areas devoted to building actuators, and it's just massive. So they're looking, and they've got all these areas where they're looking to optimize. So, because you can just imagine building an aircraft is just and they build almost every component of it as well. And so you can just imagine the complexity of this whole process. So they're looking for ways to introduce IoT data into their system. They want to gain efficiencies in the development process or the building process. They want to increase their quality, make sure that everything is cranked out as they want it to be. They want to make sure that their assets are tracked for health and are for maximum utilization. And of course, they want to make sure that their people are safe and that they're up to regulation there. Of course, they want it to be manageable and scalable, and everybody wants it to be secure, but in their case, they really want it to be secure because they have a lot of top secret stuff going on there. So they started off with a small project, and by the way, I would recommend this too for folks that are working in IoT sorts of things is that it's kind of think of it as a leadership exercise, that they realized if they came up with a very small use case and they delivered data to Pi, then it becomes very obvious, and they can do it very quickly, then it becomes very obvious to other people the value of it, and then it becomes much easier to roll out additional functionality. So they started off, they've got a series of paint booths. They've got 5 or 6 paint booths, these enormous things, and the challenge is it's not just cosmetic. That when you're building an aircraft, it can impact the flight characteristics if the paint isn't right. And so if the temperature isn't right and it dries improperly or it's too heavy, then they have to take the wing or whatever piece off and they have to go and sand it down and maybe tear it apart and redo it. And it can lead to some pretty dramatic delays. And of course, that's a problem for their customers as well. So again, they're looking for a quick win. They're also looking for something that, or they were looking, because this has now happened, for something where there's very small or even zero impact on the IT teams, the security teams. They want something that's just easy to plug in. So here's what they built. They went out and bought a few PT100 temperature sensors. These things cost 40 or 50 bucks. They hooked it up to a Raspberry Pi, another 30 bucks. They installed Fog Lamp free. And then they hooked it through a Pi connector relay to their Pi server, and now they've got access to the temperature data in this paint booth. And so in addition to getting alerts through the Pi system and seeing, hey, we really need to worry about this temperature, they also can do all the standard things that you would expect in Pi. So they can go back and do diagnostics later and worry about why the temperature wasn't what they expected it to be. It's easy enough for them to go and add additional sensors, particulates things, see what's floating through the air, see the humidity, and whatever other sorts of things you want to throw into the system. So this has turned out to be a successful project. So now the next piece is that how do you now scale this up? Because 1,000 of anything is hard. And you've got all kinds of problems. So first of all, you've got to provision it. If you've got tens of thousands of gadgets out there, how do you know which one is which? How do you know where they are? How do you fit them into your systems? How do you actually roll them out? And then how do you maintain them? How do you just generally manage them? How do you update them and patch them? And of course, now you have a security problem if you've got 10,000 new devices out on your network. And so ARM was a key partner in all this. And if for those that aren't super familiar with ARM, I would bet that the odds are that everybody in this room has an ARM chip in their pocket because they're in 95% of all the cell phones that are out there. They sell more CPUs than anybody else in the world because all the ones they sell are very small. They're focused on the industrial space, and they've got some great technology around IoT, including open source things. So at the heart of things, they build this this core that's actually used in the chips, the software that is the chip itself. They build the Cortex-M, which is designed for IoT. Applications. And then on top of that, they build a OS called Mbed OS that leverages some of the capabilities of that. And Mbed OS is an open source operating system. And then at the high end, they've got Mbed Cloud, where this Mbed Cloud, the purpose of it is to allow you to manage these devices. So if you have a chip that comes out of the factory and it's got a cryptographic signature on it, well, by the time it gets delivered to the plant floor, it's already connected through its cryptographic signature to Mbed Cloud. So now the plant manager can go out to Mbed Cloud and can know already know the characteristics of this device. They can go and deploy it, and then they can go and change configuration. They can change the operating system or the firmware or any other kinds of things about this remotely. So it's a great way to have an end-to-end secure and scalable solution for delivering these things. And they also have Mbed Edge for other devices that don't use Mbed OS. So now, coming back to this defense contractor, you've got the same picture at the top where you've got these temperature sensors flowing into Fog Lamp, flowing into this Pi server. And so ARM contributed to or is in process of contributing to the Fog Lamp source code, this capability to have Mbed Cloud manage these sensors and the Fog Lamp devices themselves. So now this whole thing becomes a much more scalable solution. And Mbed has, first of all, they have end-to-end security. As I say, they've got all the way from the chip, the cryptographic signature, flowing all the way out to the cloud. They have a variety of ways to connect inside Mbed OS. The provisioning, as I say, it becomes much easier because the devices arrive. In fact, our goal is not just to have small devices roll out to factory floors, but our goal is to have the vendors of equipment. So, maybe a riveting machine, maybe a CNC machine comes with FogLamp baked into it, and then once it arrives on the factory floor, it's already ready to talk to Pi. It's already ready to be provisioned by the existing tools that are out there, and so it makes for a very easy and scalable solution. And there are also some key security features inside Mbed's OS platform. So in the core itself, they have TLS capability. TLS is the protocol that's used for securing communications, for doing authentication. So in HTTPS, TLS is the stuff that makes it secure. But they have a way of doing that inside the chip so that, first of all, it's higher performance, but it's also more secure in the way it does things. They've also got, in their firmware, they have ways of doing trusted boot and trusted storage so that you have trusted areas of the chip and the device that can't be attacked from outside. And of course, they've got all the lifecycle security, the stuff I talked about a second ago with the provisioning and the device-based authentication, that sort of thing, through Mbed Cloud. So here's kind of the overall vision is that you've got these various devices out there. You've got FogLamp componentry that ties it together. And then you've got ARM that's enabling you to doing the provisioning, the lifecycle management, and the security. And of course, ultimately, the data is delivered out to Pi to do all the sorts of storage and analytics and all the ways that you utilize the data that's inside Pi that we're all familiar with. And as I say, the open source standards are critical. FogLamp is, like I say, it's a great community that's growing, and hope to get some folks involved and embedded in it. And as I say, ARM has been a fantastic partner in this whole thing as well. And of course, OSI is key to the data management and everything. If you'd like to learn more about FogLamp, there are two other talks. There's on Thursday at 10:30, there's a introduction to FogLamp. And then at 1:30, there's a lab, and this lab is actually really cool. I don't know if it's sold out or not, but it's worth checking into if you want. There's everybody has a little remote control car, and they have a little Raspberry Pi on it that has some sensors, so it can detect lights and can detect temperature and stuff. And you put FogLamp on it, and you get your own data flowing into it. And then there's a little contest where people run them around and stuff, and it's big fun. And then at 2:30 on Thursday, there's a talk on fog computing on the plant floor. And we've got a community booth. As I say, there's some great partners in there now. So OSIsoft, of course, ARM, of course, Sprint, of course, Toshiba, Arrow, Panduit, BTE. I'm probably forgetting people. And if you'd like more information too, please check us out at Dianomic. And then also you can go and get FogLamp today from GitHub. So it's github.com/FogLamp. And I think that's everything I got. Any questions, any thoughts?
Anybody with any questions, comments, jokes?
Jokes. Yes, sir.
You said you're talking to the machine manufacturing level folks about embedding this in their devices. Are you talking to people like Bentley, Nevada, System One, or anybody at that level?
So to be honest, we're fairly early in that. So the folks that we're really talking to now are either direct end users of FogLamp or SIs who will integrate into various folks. Actually, at this defense manufacturer, they've introduced us to two folks that are building these giant automated CNC machines, and another one is this giant riveting machine. But to be honest, we're very early in those kinds of discussions. I would say that statement is really more of a vision statement. That's what we're really looking for right now. One of the challenges with the whole IoT world is that you have all these evolving standards, and so that's the reason why we think that open source is so key to this. Is that so? Are people going to use the the GE solution? Are they going to use the Dell solution? Well, we think that the right way to do it is to do something that's free and so pervasive and so, not geared to a specific vendor, but something that's really for everybody, that's the way you're going to get common usage across everybody. And so we're excited to talk to anybody that's, if you have specific suggestions beyond those ones. I'm not sure if I answered your question other than no, we're not really doing it yet. It's just vision. Yes, sir.
I got a pretty loud voice. Just a quick question. All the tools that you were talking about, are they available on every IP core? Or is it a special option that like an Intel or a Boeing or somebody would have to request?
Sure. So FogLamp itself is available on Linux today, and it's in process of moving to Mbed OS as we speak. In terms of what's available in Mbed Core, so by the way, I'm not from ARM, and I don't have somebody here to answer ARM-specific questions, but the Cortex-M has the TLS in it, and I'm not sure if Cortex-A does or if it doesn't. You're specifically asking about?
It's just a personal
Sure.
interest. I came from that world and I did a lot of work in that area, so I was just kind of curious if this is something that they were doing as a broad stroke, that it's there for people to access whether they want it or not.
I believe that's the case. To be honest, I can't really say for certain what ARM's direction is on that, but I believe that's the case, is that they're looking for this to be pervasive throughout everything, but especially on the low-end IoT devices where it's low power and low cost, and having that kind of flexibility in all of them.
Thank you.
You bet.
Of course, it's across the room. Exactly.
So just a question on the self-service and the plugins.
Yes.
So what type of plugins do you have already, and what's your plan for expanding?
Yeah, that's a really good question. So first of all, today we have a fairly limited set. So there's you can directly connect a device to it. So if you've got a sensor that's physically connected to your hardware, that's fairly easy to do. We've got ones for CoAP, which is a very lightweight HTTP. You can think of it that way. It stands for constrained. Well, the CO is for constrained. But it's very similar to HTTP. It's got the same verbs, that sort of thing. And then we also have an HTTP or HTTPS plugin. The way that we're looking, so there's additional ones that are being developed as part of working with customers. But what we're really looking to do is build a community where other folks are pulling these in. So that's really a very good question. So other ones that seem to be obvious that would be next ones would be OPC-UA and Modbus. But beyond that, it's really a question of what does the community want and what does the community want to build into it. You bet. Hey,
Hello. Hello. Hey, have you guys, I know you're using OMF, but have you considered using MQTT or a pub/sub type communication model protocol?
Yeah, it's an interesting question. So we're considering MQTT. Well, so MQTT clearly needs to be part of this. And so there's both a question of like on the output side, on the northbound side, as well as on the southbound side. So certainly MQTT is on the roadmap, but exactly where it fits in is probably going to be determined by customer demand, because as you say, putting it on the northbound side is important. And then there's a question: okay, well, what is the where is the data actually sent to? Are we the host of it? And how does that flow in from the southbound side? So, truth is, it's a future piece. But I will say this as a general direction is that right now our focus on the northbound side is pretty exclusively on OSI, because OSI is such a strong partner, and at the end of the day, this is delivering data out to the OT networks. The other outbound side is really to another fog lamp device. So if you've got a fog lamp in a sensor, sending to an aggregator, sending to another aggregator, and then sending to EDS or PI or OCS. But certainly MQTT will be a future addition.
All right. Thank you very much, Bill. Let's give him a round of applause.
Thank you.